Okay, so let's start exercise number 1, making a homopolar motor, the world's simplest motor. So we've got magnets, AA battery, a wire, and a screw, a steel screw. Aluminum screws don't work. So the first thing I'm going to do is take the screw and stick it on the magnets. So aluminum doesn't work. Of course, screws normally don't come in aluminum, but you may get one like that. Then I'm going to move the iPad sideways so we can actually watch this. It's kind of hard to do this. So now I'm going to take the battery and hang the screw from the negative side of the battery like that. Now, I'm also going to put a little tag on it so we can see it move one way or the other. And so this way we can figure out what direction it's moving in. It's actually, I just grabbed it off my tomato that I had in the kitchen. So what I'm going to do now is I'm going to put this wire, and I took the insulation off the ends. I'm going to put one end at the positive end, and I'm going to touch it on the battery. So it's a little wiggly, but watch what happens when I do it. It'll start moving in one direction. Okay, do you see it? Okay, do you see what direction it's moving in? So let's do it again. See how it's hanging like this? Let's stop it from moving. All right, so now the tag's on the right. All right, so you see the direction it's moving in? Now, what we're going to do is several things. Now that we got it to move, what we're going to do is switch the battery upside down. But I'm going to keep the screw in the negative end. To do that, I just have to go off screen a little bit. So I'm flipping the poles of the battery. That means the magnetic field is going in the opposite direction it was before. Now I'm still going to hang it from the negative end like this. And now what we're going to do is see what direction it moves in right now. All right, so I'm going to do the same thing. Up. Do you guys see it moved? I'm going to do that again. Stop it. See what direction it moves in? It now spins in this, well, if you look really careful, you should have noticed it's going kind of fast, but let's see if I can get it to move a little slower. It seems to be doing happier now than the previous one. All right. So you should be able to see what direction it's moving in. So what I'm going to do is I'm going to flip the battery back to where it was. I'm going to take the little tag off. And we're going to do it one more time the way it was originally. Then we're going to flip the battery upside down so that the current will change. So right now, I have the same situation I had at the beginning. You can see it's going the opposite direction. All right. So flip the battery around. And this time, I'm going to hang the screw from the positive end. So what I'm doing is flipping the current around. So let's see what direction it moves in now. Okay. So you got it. So let's really simply flip the battery around again, just in case you didn't notice. So now I've got the negative end, and there you go. So the only other thing we want to do is add some more magnets. So I've got more magnets. Oops. I just put the poles in the opposite direction. It was repelling. All right, so I got a lot more magnets on here. All right, so all we want to do is see if it spins faster or slower. So let's just look at this thing moving here. Oh my gosh. All right, it's spinning so fast that my tab fell off. Okay, so it obviously spins enormously faster when you put more magnets on there. So you stir the magnetic field, the force increases. You should have gone over how this type of magnet works. It has to do with the cross product, the F equals Q V crossed into B.